Yo, Wagwan. It's Mr. Garfield here, and today we'll be looking at a January 2016 past paper question. All right, and we're dealing with section 8, that is geometry and trigonometry. And here we have a circle geometry question, all right, where we have to apply the theorems of the circle and other things in geometry, right? And here it says the diagram below, not drawn to scale, shows a circle with center O, tangent TAE, right? TAE is a tangent to the circle at the point A, okay? And it says angle AOD is equal to 72 degrees, okay? And clearly we can see that. Great. So let's just answer some questions here. The first part of the question says, calculate, giving reason for your answer, right? Calculate giving the reason for each step of your answer, the measure of angle ADC, angle ACD, angle CAD, and angle OEA. All right? So let us do that here. All right, so we're going to do the first part of the question, which says we have to calculate angle ADC. Okay? Angle ADC. Let us look at where that angle is. So here we have A, D, then C, right? So we're talking about all of this angle right here. Okay, all of that angle in red, all of that angle there. Now, what do you think? What is that angle? Well, that angle there is actually 90 degrees. Okay? That angle there is 90 degrees. So I'm going to write my solution here. So this is part 1. All right? Part 1, solution. And we are saying that the angle ADC, all right? The angle ADC is equal to 90 degrees. Why is that? Well, there is a theorem which says that every angle at the circumference of a semicircle, all right, so I'm going to highlight this semicircle that we're looking at, okay? I'm going to highlight the semicircle. So all of this here, all right? So all of that there is the semicircle, okay? So all of this here, all right? All of that there is a semicircle. Good. Yes, so the theorem says every angle at the circumference of the semicircle, all right, that is connected by the diameter, CA is a diameter, all right, CA is a diameter, or if you want to say COA is a diameter, okay, that line there is a diameter. So the rule says every angle at the circumference of a semicircle that is connected by the diameter of the semicircle is a right angle. Okay? Is a right angle. Good. So that is going to be my reason. All right, so I'm going to write it here. So my reason is every angle at the circumference of a semicircle, every angle at the circumference of a semicircle, all right, that is connected by the diameter, that is connected by the diameter okay, of the semicircle, is a right angle, is a right angle. All right, so that's my reason, which says every angle at the circumference of a semicircle that is connected by the diameter of that semicircle is a right angle. All right, now this word here, which says connected, some persons may use the word subtended. All right, so persons may use the word subtended instead of connected. They really mean the same thing. Okay, good. So the angle at the circumference is that angle here labeled in red. All right, that is the angle that we're talking about. So this angle here at the circumference of the semicircle, all right, which is connected by the diameter of that semicircle that I have highlighted for you, all right, is a right angle. Another way of saying this as well, I think in the previous video that I uploaded for circle geometry, I stated that the angle at the center is 2 times the angle at the circumference. All right, you could also use that reason as well. Okay, you could use that reason as well. All right, you could use that reason as well. Why? Because this rule here, all right, the angle at the center here, all of this angle, all right, that's all of the angle is going to be 180 degrees. Okay, that's the angle on the straight line and the diameter there, right? So we know that the 180 degrees, all right, which is the angle at the center, is going to be equal to 2 multiplied by the angle at the circumference, which they asked us to calculate. That is angle ADC. All right, I'm just giving an alternative way of calculating the same angle. All right, using a different reason. Okay, so it means that if I want to find angle ADC, what I would have to do is to divide both sides of the equation by 2. All right, so if I divide both sides of the equation by 2, I will get angle ADC being equal to 180 degrees over 2. All right, and angle ADC is going to be equal to 180 degrees divided by 2, which is 90 degrees. All right, so I'm just giving you an alternative method of calculating the same angle, okay, using a different reason. And the reason here that we're saying is that the angle at the center is 2 times the angle at the circumference. Okay, great. So we have now finished part 1 of the question here. All right, so we're now going to do part 2, angle ACD. Okay, part 2. Solution. All right, and we want the angle ACD. Okay, we want to find angle ACD. That is what we're trying to find, right? Good. Let us just identify that angle here on the circle. Okay, that is angle ACD. So here we have A, C, then D, right? So they're talking about this angle here, angle ACD. Okay, good. Now, how would I find that angle? Well, I want you to observe something carefully. Let us observe this angle here, okay, and the chord here. All right, so we're going to observe this chord here. AD, that line is a chord. Okay, that's called a chord. Good. Now, there's a theorem which says that if two angles stand on the same chord, right, then we know that the angle at the center is 2 times the angle at the circumference, right? So that is the knowledge that I'll be using to calculate this statement, this angle here, right? Angle ACD, all right? Yes. So we want that angle, which is angle ACD, all right? Now, previously we calculated the angle ADC here, right? And we said that it was equal to 90 degrees, and I showed you 2 methods really in calculating that angle, all right? And one of the reasons that I said is that the angle at the center is 2 times the angle at the circumference, right? Now, what I want you to understand is that the reason which I stated over here, all right, when I said that every angle at the circumference of the semicircle that is connected by the diameter of the semicircle is a right angle, that is actually a special case of the theorem which says that the angle, the 2 angles which stand on the chord, right? If 2 angles stand on the same chord, then the angle at the center is twice the angle at the circumference, right? That is a special case. So that is a special case, all right? So yes, we stated that these angles here, which I have highlighted in yellow, all right? What do you know about those angles now? All right, now clearly this angle here labeled in red, okay? So let me take off this angle here, good. So this angle here labeled in red, all right? That is the angle at the circumference, right? That angle is at the circumference. So what can we say? Now clearly you see that these 2 angles stand on the same chord, right? AD is the chord that we're speaking about. So if 2 angles stand on the same chord, then the angle at the center, which is the 72 degrees, okay, that is going to be 2 times the angle at the circumference, which is what we want, right? That is angle ACD, angle ACD, all right? And that is the equation that I'll be using to find the angle ACD. So let's just do that over on the other page here, all right? So we are saying, let me erase this. So we are saying that the 72 degrees is equal to 2 times the angle ACD, okay? 2 times the angle ACD, good. So I want the angle ACD on one side of the equation, so I need to now divide both sides of the equation by 2. So if I do that, it means that this 2 here, all right, this 2 right here will end up being canceled out, all right, which will leave me with angle ACD being equal to 72 degrees divided by 2, okay? So angle ACD is equal to 72 degrees divided by 2, which is 36 degrees. All right? So 36 degrees is my answer for angle ACD. So I'm going to write my reason here now. All right, I'm going to write my reason. So if 2 angles stand on the same chord, then the angle at the center then the angle at the center, all right, the angle at the center is twice the angle at the circumference. The angle at the circumference. Good. So that is our reason. Great. So we are now finished with the second part of the question, all right, which is angle ACD. All right. Now, I would just like to go back to this angle here. All right. I would just like to go back to this angle that we were speaking about. All right. The first angle that they asked us to calculate, that is angle ABC, which is equal to 90 degrees. All right. And we stated that the angle in the semicircle is 90 degrees. Okay. And what I'm saying now is that that theorem is really a special case of the theorem which says that the angle at the center is 2 times the angle at the circumference. Okay? So I hope that was clear. Good. Let us now proceed to the other question. The third part of the question says that they want angle CAD. Okay? Angle CAD. What is that angle? Let's just look in the circle here. All right, angle C, here is C, then A, then D. So it means that they want this angle A. All right, that angle right there. Good. Now, how would we calculate that angle? Well, I recognized that this angle and this angle are going to be the same. Why is that? Well, let's just look at it carefully. Remember now that COA is a diameter, right? That's the diameter of the circle. Okay, so it means that OA and, all right, so OA and OD, all right, OD, those two lengths are equal. How do I know that? Because OA and OD are 2 radii, all right? And those radii must be equal, okay? So OA and OD must be equal because they are the radius of the circle, basically what I'm saying, all right? And we know that when that is the case, the triangle that is going to be here, right? The triangle AOD is going to be an isosceles triangle. And in the isosceles triangle, it means that the base angles are the same. Hence, this angle is the same as that angle. Those are the base angles that we're speaking of. Okay? So I really hope that that was clear for you. Okay? Good. Now, I need this angle here, which is CAD. All right, so I'm going to call it Y. All right, I'm going to call that angle Y. And I'm also going to call this angle here Y, right? Because both of them are the same. So it means that those angles are equal. Okay, good. Now, how do we now calculate the value of Y? Well, we could use the rule which says that, or the fact which says that the sum of all the interior angles of the triangle, all right, is equal to 180 degrees. Okay, so I'm going to use that statement as well. I'm going to use that fact as well. All right, so we know that 72 degrees plus y is going to be equal to 180 degrees. So let's just write that work in here. All right, we're going to write that work in here. This is now part 3, solution. Okay, good. And we are saying that the 72 degrees plus y plus the other y is going to be equal to 180 degrees. All right, those are the interior angles of the triangle. 72 degrees y and y are the interior angles of the triangle. So it means that when we sum those angles, we must get 180 degrees. All right, so I will now have 72 degrees plus y, that's 2y, which is equal to 180 degrees. All right, I want y alone on the left-hand side of the equation. So what I'm going to do is to subtract both sides of the equation by 72. Okay, now if I do that, it means that when I subtract 72 degrees on the left-hand side, I will get 2y remaining. And on the right-hand side, I will have 180 degrees minus 72 degrees. All right, so 2y is now equal to 180 degrees minus 72 degrees is going to give us 108 degrees. All right, 108 degrees. And y would be equal to what? So we have 2 multiplied by y, which is equal to 108 degrees. So what we could do to get y by itself is to now divide both sides of the equation by the 2. All right, so if I divide both sides of the equation by 2, on the left-hand side of the equation, the 2 will be gone, right, because the 2 will be cancelled out. On the right-hand side of the equation now, I will have 108 degrees divided, I will have 108 degrees divided by 2, right? So y is now equal to 108 degrees divided by 2, that is 54 degrees. All right, and 54 degrees is my answer. So we are saying now that angle CAD is equal to 54 degrees. Okay, good. So my reason here now is that the base angles of the isosceles triangle, the base angles of the isosceles triangle that triangle was AOD. All right, so that isosceles triangle. So the base angles of the isosceles triangle AOD are equal. All right, they are equal. Good. Also, we know that the sum of all the interior angles, the sum of all the interior angles of a triangle, all right, the sum of all the interior angles of a triangle is what? 180 degrees. All right, good. So those are the two reasons, okay, that we used to calculate the result. All right, good. So we have now finished part 3 of the question. Okay, part 3 is now completed. Let us know the part 4, which says that they want the angle OEA. All right, so part 4, let's just write it down here. Part 4 solution. All right, let's go back to our diagram. And we want the angle OEA. Okay, so I'm going to highlight it in blue. Okay, that's OEA, which is all of this right here. All right, that angle right there. We're talking about that angle. All right, now how would we calculate that angle? Well, we know that all of this angle here, all right, all of that angle is 90 degrees. Why? Because you should know that the radius, all right, the radius which is OA is perpendicular. All right, so the tangent which is TAE here, let me just scroll in a bit. the tangent TAE here, that line on the outside, is perpendicular to the radius. All right, the radius here is OA. Okay, so you should also know that as well. So you can see that the tangent TAE meets at this point here. All right, it touches the circle at that point, which is A, and A is what we call the point of tangency or the point of contact. All right, so that angle there, okay, which is at the tangent, all right, where the tangent meets the radius, that angle there is 90 degrees, okay? And if you look carefully, OEA is a triangle, all right? To be more specific, it is a right angle triangle, okay? And we know that this angle here is 90 degrees, okay? So that angle there is 90 degrees, and we have 72 degrees here. So it means that if I want to find the angle OEA, all right, which is this angle here, then it means that I can just call this some letter X, all right? And I know that X plus the 72 degrees plus the 90 degrees is going to be equal to 180 degrees. So we're using the rule which says that, or the fact which says that the sum of all the interior angles of the triangle is 180 degrees. So let's just write that down here. All right, we're going to write that down here. So we are saying that the 72 degrees plus the 90 degrees plus X is equal to 180 degrees, or aim is to find X. So 72 degrees plus 90 degrees, that's 162 degrees, plus X equals 180 degrees, okay? And X is going to be equal to what? So I want X alone on this side of the equation. So what I'm going to do is to subtract both sides of the equation by 162, okay? And if I do that, then the 162 degrees on the left-hand side will be canceled out. And on the right-hand side, what I will have is 180 degrees minus 162 degrees, okay? So X is equal to 180 degrees minus 162 degrees. So X is going to be equal to 180 degrees minus 162 degrees, that is 18 degrees. Okay, so therefore it means that my angle OEA equals 18 degrees. All right, that's what I'm saying. Good. Let's just write our reason here quickly. So we're saying that the tangent TAE, all right, that line that touches the circle at the point A, is perpendicular to the radius, all right, is perpendicular to the radius OA. Good. Also, we use the fact that the sum of all the interior angles, all right, the sum of all the interior angles of a triangle is 180 degrees, all right? And that is my reason. So I am now finished with the last part of the question, all right? I am now finished with the last part of the question. Good. So it means that I am now finished with this past paper question from the January 2016 past paper. Okay, I really hope that it was helpful. And if this video helped you in any way, please ensure to like up the video and subscribe to the channel. All right, and please don't be afraid to comment down below. Okay, and also let me say that for these type of questions, they can be done in different ways. All right, you know that mathematics has different ways of solving problems, right? So I might do a question one way and another teacher might do a question a different way, all right? It is just important that the reasoning is correct, okay? It is mathematically correct, it is logical, okay? Good. So with that said, I am Mr. Garth Reed, student ambassador for the University of Technology Jamaica, and I'm a mathematics teacher in training. in the School of Mathematics and Statistics. I thank you for joining.